this is Britt Caswell with another example video. In this video, I'm covering example 6 from section 2-4 in the SavvasRealize Algebra 2 textbook. So in this video, we are looking at solving a quadratic equation with complex solutions. So it starts out with a problem where they're asking us to solve this equation using factoring. So notice that the equation is set equal to 0. You always need that if you're going to solve using factoring. So I need to factor x squared plus 4. Well, that is a sum of squares. So I'm going to break the x squared plus 4 into two sets of parentheses. Now remember, they're separated by a plus and a minus, and there will be an I at the end of the second term. So the square root of x squared is x, and the square root of 4 is 2. Alright, so that is factoring using sum of squares. So now that we've done that, now I'm going to use what's called the zero product property. So the zero product property, recall, it says if you have two terms, property. It says if you have two terms that are being multiplied together and they equal 0, then either the first term is equal to 0, the second term is equal to 0, or they're both equal to 0. So if I set each of these equal to 0, then I can solve and find x. So here I'm going to subtract the 2i to the other side of the equation. So I have that x equals negative 2i. And here I would add the 2i to the other side of the equation to get x alone. So I get x equals positive 2i. So these are my two potential solutions. Notice that because they have i's in them, they are imaginary. Alright, so in this example, okay, again we have a sum of squares. So I break it into two sets of parentheses. Make sure that this equation is set equal to 0 or you're going to be messed up. You're going to have a plus and a minus, and then an I in the back. So the square root of x squared is x, and the square root of 49 is 7. And then I need to use my zero product property and set each of those equal to 0. So I have x plus 7i equals 0, and x minus 7i equals 0. So in this case, I'm going to subtract the 7i, and I get x equals negative 7i. And then on this side, I need to add the 7i. So I get x equals positive 7i. And those are my two solutions. Let's try one more. So again, it's set equal to 0. Yeah, just one more. So it's set equal to 0. So I break it into two sets of parentheses. I pop an I in the back for each one because it's a plus in between them. I put a plus and a minus. So the square root of 9x squared is 3x. And the square root of 25 is 5. So then using the zero product property, set each one equal to 0. So I get 3x plus 5i equals 0. And 3x minus 5i equals 0. So here I'm subtracting the 5i over. So I get 3x equals negative 5i. But then my x isn't quite by itself yet, right? It's not isolated. So we have one additional step where we have to divide that 3 out. So I get x equals negative 5/3 I. Let's look at this again, but with this other one. So I need to add the 5i over. So I get 3x equals positive 5i. And then to isolate x, to isolate the variable, I divide by 3. and I get x equals 5/3 I. And there we have it. So that is how we solve quadratic equations with complex solutions. Until next time.